Yeah. So this is a two-day workshop. We'll have 2 hour session today as well as tomorrow. And our intention is to understand what machine learning is, what are its capabilities, right? And we'll also see a couple of algorithms. We'll work on algorithms to understand the end-to-end of the usage of machine learning. Okay, so I have divided this topic into 2 parts, agenda for day 1 and day 2. So today we are going to talk about um, the machine learning, as I said, why it matters and where it is used, how we use it. And tomorrow we will look at hands-on examples with regression and classification examples we'll do. And then we'll talk about different career options. So first topic I'm going to cover today, and the last topic we're going to cover tomorrow. Okay, so so what is machine learning, right? um, See, when we attend a classroom training or any kind of trainings, what we do is we do human learning. That's what we call it, right? Learning. So learning basically is human being learning. So we as a human beings, we want to learn, so we get to a classroom. So we don't only just learn from classroom, but we also learn from environment, right? When you see your friends, colleague, when you see TV, when we read newspaper, right? Or you watch a YouTube video, or you read a blog. So there's a different ways for us to learn, right? And for the same reason, when we make machine learn, okay, we call it machine learning. Okay, so that's a crude way of defining what machine learning is. We are trying to train the machine. So how does machine learn? Machine learns using algorithms, using programs, right? And that, and of course all of you are from this background, so you know that we have so many different types of program, and those programs we write to make our machine do some activities. But there is a difference between automation and learning, right? When I tell you take left, take right, do this, do that, you're not using your brain, you're just following what my instruction. So when we write an instruction of, say, add sum of two numbers, right, we are not making machine learn, we are giving them the instruction. Okay, a equal to 5, b equal to 6, c equal to a plus b, print c, right? So that's not machine learn, that's not, machine is not learning there, machine is only following your instructions, right? So that's why sometimes we also call as instructions. Earlier the code was called as instructions, you are instructing machine to learn. When do we learn? So if I tell you to go to railway station, Secunderabad railway station, now which mode to take, whether you want to go by bus, by metro, by train, MMTS, or you take your auto, you take a cab, you take your bike, those decisions I'm not instructing you, right? Those decisions you are making. Okay, so this is the traffic way, so I have to follow different route. At signal you have to stop. All those instructions. Okay, I'm just telling you follow this route and go to. I'm just telling you go to Secunderabad. All the decisions you are making, because you have the capability to make those decisions. And let's say if I tell you to give you a bike, and you're in different city where you have never been to that city, if I tell you go to railway station, you'll ask me for instructions. You're asking me for instructions when you don't know how to do what to do. But when you know, you will not wait for my instructions. So same way, when we make machine learn, we want machine to make those decisions. We don't want to make those decisions for machine. We don't want to instruct every line of code. Okay, we don't want to give every line of code, go straight, take left, go for 5 steps, okay, then take right. Okay, the instructions will be much longer than if you train the machine. If machine is learned enough, then they can take a decision on themselves. Okay, so that's the whole idea of training a machine, so that machine doesn't depend upon our instructions. Okay, that's how the machine learning programming is different than other programming that you would have done before. If you have not done, assuming that you have not done, if you have done algorithm and machine learning, then probably you know this difference. And second point I want to make here is, before we get down to the technical definition, is, see, as a human being, okay, the most intelligent, or sorry, the most important thing that we own, okay, is not gold or silver, but our intelligent, right? Our brain is the most expensive or most prized possession that we all have, right? So now if we talk about gold and diamond and silver and things like that, we have artificial diamond and artificial gold, right? Then if intelligence, if the brain is the most um, important thing that we all have, then why not even make artificial brain or artificial intelligence, right? It makes sense, right? If you can make artificial gold, then we should be able to make artificial intelligence and artificial brain. And that's where the concept of machine learning and the artificial intelligence came up. That we want to make our brain do or relax and create an artificial brain which will perform different activities for us. Okay, so that's the whole gamut, and of course artificial intelligence is much bigger concept than machine learning. Machine learning is a part of it. So what does machine learning do? So in machine learning, what do we do is it's a method of data analysis, okay, that automates analytical model building. Okay, so couple of things here, right? One is data analysis. Okay, so why is data important for machine learning? Now, I always give this example. If you ask a 5-year-old or 3-year-old girl whether it's going to rain tomorrow or not, right? And you ask same thing to a 30-year-old person or 40-year-old person, whether it's going to rain tomorrow or not, right? So they will give their response. But whom are you going to trust? You're going to trust the elder person, because elder person has lot more knowledge, experience about weather than the 3-year-old. What is the difference between 3-year-old and 30-year-old? Difference is the experience or the data. The 30-year-old person is more experienced, has lot more data, has seen lot more things in the past than 3-year-old. Now, who's right is a different question. Maybe 3-year girl would have been right. She said yes, it will rain. It did rain. But then you're not going to lose the confidence in the 30-year, because person you expect has more knowledge, more experience, will be able to take better decision in long term. So when you do it for 10 times, okay, you expect that elder person to make more correct decision than just one time. One time, yeah, anybody can be wrong. So here we are trying to predict. Okay, we are trying to see what will happen tomorrow. And of course, when you talk about prediction, you can never predict with 100% accuracy, right? Uh, so things can go wrong, fine, but we are going to trust the algorithm which has a lot more data. We have to trust the person who has more experience. So data is what gives the algorithm more experience. So more data you provide, we say our algorithm is better equipped to give prediction for us. That's what data analysis is important part of machine learning. Then you're saying automating, right? Now, automates the analytical and model building. So again, I'm not giving line by line instruction. Go straight, take left, take right. No, the decision that they're going to make, okay, is up to them. Okay, you just give the instruction, do this, and the algorithm does that for you. So we are automating the model building. That's what we call it as model building. Okay, we don't want to give line by line instruction. That's what machine learning is all about. It needs a lot of data and it needs algorithm to work on those data and give result or output to it, to us. Okay, so it is a branch of AI, okay, artificial intelligence, where we're trying to mimic what a human brain can do. Okay, and that is based on idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. Okay, the main idea is minimal human intervention with simple code, less number of code. You want algorithms to make their own decisions. Okay, so now you can unmute yourself anytime and you can ask me questions. Okay, since this is a workshop, we will not wait till the end. You can unmute yourself and you can ask me the questions. Some questions we will answer it. Some questions we may not be able to answer because of interest of time, because we only have 4 hours today, 2 hours, and tomorrow 2 hours for this workshop. So not every questions we can answer, but something relevant, something more related to the topic that we are going to cover, definitely we will answer. So you can put your question in the chat window, or you can even unmute yourself and ask. Okay. So now the question comes, why are we learning machine learning? Is this something new? Okay, the answer is of course no. It's not something new. And most of the concept of machine learning is based on concepts which we have already done in the past. The biology, okay, bioscience or biology have been using this for hundreds of years. Why it is important for computer science community these days is because of the availability of data. Right now a lot of data is generated every day. Okay, this was not the case pre-computer time. I mean, of course it wasn't the case 20 years back. In last few years we have seen that lot of data is being generated. Okay, and data is of course of large volume. Lot of data is being generated. Not only that, they are from variety of sources. They get generated from variety of sources. So earlier we used to talk only about say text file, and then we used to talk about database, right? RDBMS kind of system. But now data has gone beyond RDBMS system. So sometimes data is even unstructured. When you talk about voice data, video data, right? Or data from Twitter and things, Facebook data, right? All these, they do not have any kind of form structure. There's no form or the structure. So you have data from variety of sources, large volume of data, and also granular data. That means data are specific, related to each other, which will help us to make. It's not random data. Okay, it's not like we have some data from one business, some data from other business. Okay, it's a granular data where it can be used to make some meaningful or intelligent decisions. Okay, so because of these regions, and of course the cost of storing data, like, the cost of hardware has come down. The hard disk cost has come down. So what has happened is it has given us the ability to store large amount of data. Now, as a business, you can choose to ignore, or you want to apply some logic, some algorithm to make sense out of it. Now, the companies which choose to ignore will not see their, they are losing a very important or competitive tool. Data companies which are making sense out of the data, we are using the data to analyze and predict. Of course, are going to do well, right? So that's why, because of this competitive nature, earlier, 5 years back or 10 years back, we talk about Facebook or Google or even Microsoft, they were into this for long time, right? They were using it. Other companies probably they didn't have capability or they didn't want to do it. Now it has become something like this, that if you don't use this, your business will go out of business, right? You're going to go out of market. So because of which every company these days are talking about this. Okay, every company in the world, okay, are talking about, and how to use this data that they generate, how to use that and make sense out of it, how to be more competitive. Okay, and that's why there is a lot of interest in this subject. Okay, now as I said, artificial intelligence is the bigger picture. Okay, the main is a superset of everything. Okay, and you'll hear words like data science, big data, deep learning, machine learning. Okay, so all these are subset of artificial intelligence. Artificial intelligence is mimicking like a human being. Okay, so when you talk about a human being, we think, right? We make decisions, and also at the same time we execute a decision, right? So when you talk about artificial intelligence, it's a lot more than just decision. It's also about execution. So whether we talk about robotics, okay, all those things are part of our artificial intelligence, where the robot is able to think and also make some decision, make able to execute a decision. So it is artificial. If you look at it, goes beyond just a computer science subject. Okay, yeah, you have mechanical, you have electrical, you have electronics, all those things together. Okay, you would talk about artificial intelligence. Machine learning, which is our area of focus, is subset of artificial intelligence, where we are only thinking about making or taking a decision. Okay, we are only about making a decision. So if you see, machine learning is bigger chunk of AI, right? The bigger chunk of AI is machine learning, and here we are only talking about making intelligent decisions. Okay, we are training the machine, we are making sure the machine learns so that they can give a better result. Okay, and then you have other topics like big data and deep learning, which becomes very specific. And also, if you see, they are also kind of subset of machine learning as well. Okay, and data science is interesting here because Generally, we use data science and machine learning interchangeably. Data science is little more than machine learning. Here, you also talk about the domain, about the business aspect, right? If I'm working on a retail domain, okay, so of course, data analysis and machine learning is part of it, but you should also understand what retail domain is, where this data will be helpful, how this data can be helpful in the domain, right? So that's why we call it as data science, which is little more than just our algorithm or the technical aspect. Okay, so that's where, but otherwise most of these things are part of our machine learning, which in turn is a part of artificial intelligence. Okay, so what is machine learning? Okay, what is machine learning? Now, in the beginning itself, I have compared this with human being, right? When you say human being, so when you learn something, okay, what we do is gradually, we are improving our knowledge. Okay, so if you compare yourself with what you were 5 years back, okay, today you know a lot more things than what you knew 5 years before, right? And again, if you compare yourself in 5 years from now, you will know a lot more things in next 5 years than what you know today, right? Because we learn, okay, whether you learn in classroom or you learn outside the classroom, different thing. Okay, so that is two types of learning, in classroom and outside classroom. In machine learning as well, there are two types of learning. Okay, supervised and unsupervised. We'll talk about it in some time. Supervised is where you learn in the classroom, unsupervised is you learn outside the classroom. Okay, so we'll talk about it in some time. But if you talk about human being, yes, we learn, right? And same thing is that when you talk about machine learning, okay, and I can talk this in terms of equation. So a computer program is set to learn, right? That means a program is a machine learning program if, okay, learn from experience E. Okay, so if you represent experience as E, then the computer program is learning from that experience E, and I told you experience nothing but time or more data, okay, with some class of task T and a performance P. That means with, you have given some data to machine learning, and machine learning, and you have asked the machine learning to perform some task, okay, and the performance is like, let's say it is 70% accurate. So you measure the performance as well, right? You give it a task and you also measure the performance P, right? So E is the experience. So let's say you have given some say um, say say 100 MB of data. Let's say, so okay, so you have given 100 MB of data, and uh, you have asked it to perform some T. They want to predict if the customer will buy your product or not. Okay, and the performance measure is P. So you see that 70% of the time your machine learning algorithm is getting it right. Now, if you provide more E, that means if you provide more relevant data, okay, not any data. When you provide more relevant data, okay, so if you talk about your engineering, of course, if you just focus on engineering knowledge, your fourth year knowledge will be better than your first year knowledge, because you are getting similar input in all the semesters, right? So if you give similar kind of data, okay, you are increasing the experience E. And now if you measure the performance on the same task T, so T is not changing, okay, T is same. And if you provide more E, your performance has to improve. If I give more data, okay, 100 and 200 MB of data, in this case, if I predict the same task, okay, the algorithm should be able to give me a better result than 70%. It is 75. No, it could be 72 or 78 or 90. That doesn't matter. Okay, what matters is you are able to give a better result now. Okay, so that's what we say machine learning is, machine is learning. Okay, and when you take a simple program, okay, when you add two numbers or find average and sum, and I mean any of the normal program, non machine learning program, whether you run it today or you run it after 100 years or you provide more data, it is going to do the same functionality. If your program is right, it's going to give you the same result. There's no improvement as such. Here there is an improvement because there is no fixed formula. There's no formula that A plus B. Okay, so when you give more data, more information, more experience, your performance will improve on the same task T, and that's when we call it as machine learning. Okay. So machine learning can be seen as building blocks to make computers learn to behave more intelligently. We want to make, see, when you have a lot of data, okay, GBs of data, or even thousands of data, it becomes impossible for us to analyze those data with our own brain, right? Of course, like human beings are more intelligent, but then we have some capabilities. One, um, if I experience, if I know the process, if you are I can do better. But if I don't know the process, if you hire some fresher for a job, you need to give the fresher some time before he or she can perform with the same accuracy, right? So so that's one. Second thing is, it is not possible for us to go through thousands of records and make decision, right? It is just not possible because of we have some limitation. But if we can make computer learn and think like us human being, then they can handle the large volume of data. They can work 24 hours a day. We can't work 24 hours a day. They can, machine can work for 24 hours a day, right? So we are making want to make sure that these kind of work which we are doing, if we let machine do it, we can sit and relax, right? We can develop more machines who can do all this work for us, right? So that's what we call it as machine learning. Okay. Now, I just said, when you talk about human being learning, so you have two types of learning where you learn under a teacher. Teacher will tell you, okay, and then you will learn. And second type of learning is we learn from environment. Okay, you see, you see a TV, you watch a news, you watch YouTube. Okay, and then you analyze. Okay, so when you follow the instruction, it is supervised. Where teacher says, okay, sun rises in the east, we follow sun rises in the east, right? But later we realize that no, sun doesn't rise. It's the earth which moves. Sun is mostly the stationary for us, right? So supervised learning is where you learn under a teacher. Unsupervised learning is where you learn from the environment. Okay, you see and you analyze. Okay, nobody tells you this is it. Okay, so we learn. So that it's just an analogy to compare what supervised and unsupervised learning means. And also we'll talk more about these things. Then third, what you see is called semi and weakly supervised. That means it's a mixture of supervised and supervised. Okay, but the concept is same as supervised and supervised. And the third type, mainly third type, or the fourth type on your screen, what you see is called reinforcement learning. Reinforcement learning is also called as learning by feedback. So sometimes what happens is we take some action, and and if that feedback is bad, so generally when we do some action and your parents scold you, you realize that, oh, I have done something wrong. Okay, I should not do it, right? Or they appreciate, wow, what a great job you have done. Then what will do? You will do more. That is called reinforcement learning. So based on the feedback, we actually learn and then we perform. If feedback is bad, we think, oh yeah, it is bad and we should not do it. Okay, and when feedback is not good, we don't do it. When feedback is good, we keep doing. Okay, that's reinforcement learning. Coming back to supervised and unsupervised, these are the this is where we will focus more mainly. And for uh, our workshop, for this first workshop that we are conducting, our focus is mostly on the supervised learning. Okay, we are not going to talk about, we are not going to do any example on unsupervised. In future workshops, we plan to cover unsupervised learning. So in this workshop, we are not going to do practical examples on supervised learning, but of course we will understand what it means. Okay, so I'll just give you an example here. Okay, so supervised learning is, it's an algorithm that consists of a target or outcome variable. So outcome variable we know. Okay, so example could be, if I ask you, what will be the price of this house after a year? Let's say you want to make some investment in real estate. Okay, you go and see the land, and you ask the person who's showing you that what is the cost. So he'll say, okay, the cost per square yard is 10,000 rupees, let's say. Now, if you're thinking for investment, you want that 10,000 rupees to increase next year and to next year and next year, right? That's when you're going to buy that. So you will say, okay, what is the future price of this land? Okay, or after 3 years, what will be the price of this land, right? So in that case, we are talking about there's a fixed outcome, that the price of the land is a fixed outcome, right? And then you have the input, right? Input, you have the today's price, and then you bring in other factors. Okay, so in machine learning, what you're going to predict is generally represented as y. So in any of the equation, generally we write y equal to ax1 bx2, right, in that way. So the value that we're going to predict, okay, or in this case the housing price, generally we typically write as y, okay. And our intention is to find that equation between different x's. So x's are the input: how far the land is from airport, how far the land is from nearest school, how far is the land from say office, okay, corporation. So what happens is we are looking at these factors which are going to have impact on your y. So all these factors which will have impact, some factors may not have impact, okay. Maybe I'm just guessing, how far is the lake from home? Maybe that may not have an impact on the price. So in that case, we do not include that as x, okay. That is not the x we want to focus on. X are the factors which will impact the decision, okay. So for example, I want to predict, you go to a school and you want to predict how much, or as a teacher, okay, so a teacher, we want to predict how much marks the student is going to get in the 10th class board exam, let's say. So okay, so that becomes y, right? Y becomes the marks that you're going to predict. Now, to predict y, we also need to know the factors that impact y, right? So generally we represent those factors as x. Okay, so factors could be number of hours the student study, number of hours the student plays, number of hours student watch TV. Now, when you say factors that impact, some factors can impact negatively, some factors can impact positively, right? If you play for more number of hours, probably it's going to have a higher. If you're going to study for more numbers of hours, probably again it's going to have a higher impact on your Yeah, can you hear me okay? I don't know, something happened to my audio. Can you hear me okay now? Okay, thanks, Vinod. Sure. Okay. So thanks for confirmation, guys. Yeah, thanks. So I'm sorry, my audio got lost. So okay, so I was talking about the different x's which will have impact on your y, right? And and also we need to see, one thing is we need to know whether it's a positive impact or negative impact. Second thing is also how much impact it's going to have. Okay, so that we will know only when we know something about the data, right? So okay, in that area, area B where your friend had bought, and he bought at X amount, and then it became Y amount within 3 years because of so and so factor. So we know, okay, we have some prior knowledge, okay. So when you speak to a teacher has some prior knowledge, okay. So today what I'm going to talk about is something that I know, I have done it, and I'm passing the knowledge to you. So in that, one thing is, we don't have to always learn by doing, right? If somebody has already done it before, so we hear from it. That's called supervised learning, where you know the impact of uh, um, uh, the distance from airport, from distance from railway station, distance from say high-tech city, and things like that, okay. And based on that, we take decisions. So here there is some prior knowledge, okay. We don't have the exact knowledge, okay, because this land is new, this land we don't know what will happen, okay. Things do change, but in previous cases we know that if GDP grew from 6% to 8%, this was the impact on the land. If the distance was so much, this was the impact. So we have some prior knowledge, okay. So when you have prior knowledge, when you use your prior knowledge, we call it as supervised learning, okay. So here we have two, again we'll talk about concept of what is called as training set and test set, okay. Training set is the set of data set that we provide for machine to learn and then perform. Okay, learn and then what is perform here? Perform is to do the prediction, right? So we provide the training set to actually learn what has happened in the past, what has happened at other areas. So if I have to predict the marks for my student, I have to know what happened last year. Okay, so last year, someone who studied for 6 hours actually got 60 marks. Somebody who studied for 8 hours has got 80 marks. So, assuming that is true, this year, if somebody is studying for 50 marks, you'll assume that that person will get 50 marks, right? That's the knowledge. Now, as I said, right, prediction is not always right. The person can get 90 also, can get 30 also. But based on what you have seen in the training set, okay, that's the training set, you are predicting that the student will get 50 marks. That's called prediction, right? And prediction is always done on the training set, on the set that you have already worked and that you have already known. So in training data, we provide to the machine algorithm which talks about what actually happens. So it will have the set of x's and it will have the y. Okay, so you provide set of x's and y value, and we'll see tomorrow how to create those x's and y's and how to pass those to the algorithm. Okay, so we are going to create, identify those x's impact and tell them this is what has happened in the past. So now this is what is going to happen in the future. Okay, so that is the on the test set, you actually test the model and model will give some results, some output. Now, and, and we will see later that there are not one but there are tens of model under each family of algorithm. So before you select the algorithm, we have to select the families, or we have to select the family of the algorithm. Okay, so how do you decide the family of algorithms? So the first decision that you will take in understanding the family of algorithm is whether it is supervised or unsupervised data, right? So that's why we are studying supervised and unsupervised, because before you apply the algorithm, we need to know whether this is going to be a supervised or unsupervised. Okay, supervised, as I said, there is a training data, there is a past data, and you know what exactly happened in the past. Based on that, we are trying to predict for the future. Okay, so in supervised also, there are two main types of algorithms. Okay, one is called regression based, another classification based. Regression is where the output data, the y, okay, is a continuous or numerical data where it can take any value. For example, if you talk about price of the land or the sales that company will make, all these are numerical data. That means any value it can come, right? It can have 9,500, it can be 10,500, 10,555 also, you can get it, right? So any value is possible. So we call it as numeric value. And then there, if the output is numeric, that y value, okay, irrespective of x, okay, we are not focusing on x, we are focusing on y itself. The output value is continuous value. Then we say, okay, we will use a regression family of algorithms here. Okay, that is one type. Second type is we call it as categorical value, categories or categorical value. In categorical value, the output will be yes, no types. Okay, category of values, low, medium, high. Will the price go up, down, or remain same? Constant, high, low. Right? Those are called category. Here, we are not talking about any value. We're talking about the value which will happen within the given set. So the range of values. So no, range can be 2. It can be simple as yes, no, or it can have sometimes 10 or 20 or 30 possible values also. Okay, but those values are fixed. Okay, so we call them categorical values, and in that case we use classification algorithm. Okay, now okay. Now talking about unsupervised algorithm. An unsupervised algorithm, we don't know, we are not able to know the labels. Okay, we don't know whether it's yes or no. We don't know the current price. Okay, so of course, when you don't know all these things, you'll have some limitations, right? We'll have some limitations. We cannot perform everything, but there are some things we can perform. For example, if I give you talk about it. Uh, uh, when you talk about these big retailers, right? Walmart. In India, we have our own Shoppers Stop and Big Bazaar and things like that. See, they have hundreds of stores, right? Of course, Walmart has thousands of stores, but in India, we have all these stores has hundreds of stores. Now they have to, somebody in the head office in Bombay, they have head office, and the people have to see what kind of product will have to sell to the store. See, shopper stop, if you go to in one area and if you go to shopper stop in different area, they will not have same kind of product. Okay, so the product that they carry does not depend upon the brand name. Product that they carry depend upon the kind of people that come into that store. So if you go to a shopper stop in Banjara Hills, probably it'll have all high-end products than if you go to some area like say Miapur or other places, because it depends upon the kind of people that they come to the store, and the product that they'll carry will be based on the people visiting. We call it as demographics. Okay, demographics include the age, gender, the um, um, uh, you know, um, uh, the salary, the income of the family, the age group, I just said, right? So based on all these factors, they will decide what should be the kind of product that you carry, right? A store outside colleges will probably have smaller size stuffs, right? Maybe smaller Maggie packet or smaller cold drink, right? More of like, if you talk about fashion, probably more of jazzy fashion and things like that. But when you go to a house where it's where there's a family, probably it'll have bigger things, right? Bigger packets, bigger packets are more cheaper per unit, right? So it depends, right? So the store doesn't carry same kind of product. Okay, that's what I want to say. And the product that they carry depends upon the people or the demographics around it. Okay, so when you talk about say Big Bazaar, they'll have hundreds of products, right? Now for each product they have hundreds of stores. So the person who is actually managing what kind of product, we call them merchandiser, they have to plan for every store, for every store and for every product, right? Which is almost impossible, right? Then you get thousands of combinations, right? And doesn't matter, it's difficult. So what they do is they cluster their stores. They create a group of stores saying that, okay, store in Miapur is same as store in Goa, is same as store in Guwahati. So even though you have 10, maybe 100 stores, they cluster them into 5 groups or 5 clusters or 7 clusters or 10 clusters. Depending upon the demographics around it, they will say, okay, store number 1, 5, 22, 57, 98, 105, they have similar demographics. So I'm going to group them as one store. Okay, then other group. Okay, so now what happened is the 100 decisions which you were supposed to make, but now you only have to make 5 decisions or 7 decisions, right? So here you don't need to know, okay, the we don't need to know whether that person will buy or not, right? Here you're only interested in the kind of people that are coming to the store, and what you call it, group 1 doesn't matter, right? I can call it as cluster 1, cluster 2, cluster 3. Okay, there's no specific meaning like high, low, medium, right? Or yes, no, right? Or we don't even assign some value like, okay, 500 and 501, right? We just need to group them. So when we just need to group them, that's when we used unsupervised algorithm. In unsupervised algorithm, we don't know the outcome. We don't have the name for outcome variable, and we don't need, right? We just need to know, okay, which 10 stores are similar. Now, what we call them is up to us. Okay, so that's why it's called unlabeled data. There's no labeled data. We just need to create segmentation, okay, or different groups of it. So when you talk about Amazon, and when you log into Amazon, Amazon will tell you customers like you have bought these products. How does, okay, Amazon know the customers like you? When they say Amazon says customer like you, so what it has done, it has creating what is called a customer segmentation. Okay, based on our past history, based on kind of product that we have bought, on the amount that you are spending, how often you log into Amazon, and all those kind of things, they'll have millions of customers. So what they do is they will try to group them into few hundred or few thousand, maybe up 1,000 or few hundreds. And they say, okay, you fall in this group. So let's say if you and I fall in same group and I buy something, it'll show you that people like you has bought, because we fall in same group. So we have same, when they do customer segmentation, when divide the customer into different groups, we are in same group. So if I buy something, same thing will be shown to you. When you buy something, same thing will be shown to me, saying customer like you have bought this. Now, is this fixed? No, right? This is it is it is continuously recalibrated. Okay, so today I might be in different segmentation, but let's say tomorrow I'm a student today, and I spend less, and I'm in a different segmentation. I get the job, I start spending more, right? I maybe move to different segmentation. Okay, so this process of segmentation or clustering, for example, in the store, it keeps changing. Okay, and the people who are responsible for it, they keep creating these clusters now and then, and they say, okay, these clusters look similar, so I'm going to perform I'm going to do a uh, I'm going to take a common decision for the cluster. Okay, so that's where we used unsupervised algorithm, where we are trying to group or put them together, different things, without bothering about what will be the outcome. Okay, and semi-supervised is mix. Okay, sometimes you perform supervised, then unsupervised, then you perform unsupervised and supervised. So there are some algorithms which kind of does both, but the concept remains the same. Okay, supervised is where you have label data, unsupervised where you don't have a label data, where you don't even have a training set and test set. Okay, reinforcement. Okay, this is just for knowledge. It is where you get the feedback. Okay, so so there is a feedback loop that goes to it, and that decides whether you should be doing more of this or should be doing less of it. Okay, so example of supervised and supervised, I'll just tell you with this example, and I think with this example you'll be able to understand it better. So let's say I give you 4 fruits. Okay, so we have apple, we have banana, grapes, and cherries. Okay, so we know that these are 4 different fruits, and we've been taught in school, okay, when we were young, the types of fruit, and we know that, okay, this is apple fruit, this is banana fruit, and this is grapes fruit, and this is cherry. Okay, so we know the names of the fruit. So if I get a lot of bananas and apples and grapes and cherries, and I dump it in a hall, and in the 4 corners of the hall I put 4 big basket, and I label them as apple, banana, cherry, and grapes, and I tell you, okay, segregate all this fruit and put them in the different basket. Can you do that? Of course you do that, right? Because okay, apple is written, so you can read apple, and so you know what apple looks like, and you take the apple and you go and put it in the apple basket, right? So that way you'll be able to put every fruit in different basket, so you can do that. Okay, so here we knew that, okay, this is apple and the apple has to go in apple basket. We did that. Now let's say that you have never heard of these fruits before. You have never heard of this fruit, okay, and you are seeing this fruit for the first time. So you may not know the names of the fruit. You will not know the names of the fruit because you are seeing these fruits for the first time. Or if I replace this with some fruit which is very exotic and it's found only in some small country somewhere in Africa, and I get those fruits to you and I ask you to segregate. Now I still give you 4 basket. Okay. In this case, since we don't know the names of the fruit, the basket will not have a label, right? So you don't know, okay, this is apple or this is banana or cherry or grapes, but still we'll be able to segregate. Still, algorithm is able to group the stores together or the customers together because of the characteristics. What is important here? Of course, name is one. Okay, if you know the name, it's great. But more than the name, what is important here is the characteristics. Okay, so if the size, if you look at just 2 characteristics, and we'll be able to figure out both. Size will segregate apple and banana as one fruit, and cherry and grape as another fruit. Then color, red apple and green is banana. Here green is grapes and red is cherry. With just color and size, we are able to segregate these four. So that's what our mind do. When I give you these fruits, okay, and you are able to tell that okay, this is grapes because you compare characteristics of the grape that you have in your mind, right? Now this may not be grape. Let's say this is some exotic fruit, but it looks like grapes. So what happens when we see it? It matches to our definition of grapes. Okay, grape size is this, color texture is this, color, So based on that, we're trying to match the fruit, okay, with the characteristics that we have in our mind, right? And based on that, we say it is grapes. So even though if you don't know the names of the fruit, you'll be able to segregate them because of the characteristics, okay? And that's what happens in the unsupervised algorithm. We're trying to classify based on the different characteristics, okay? Okay, so this is what I explained. Supervised and unsupervised, we'll be able to differentiate based on size and color, right? So okay, size, color, shape. We say okay, if this is it, then it is apple. If this is it, then this is cherry, right? So we're able to classify. Okay. So coming back to different types of algorithms or families of algorithms that we have. The first thing that we have to identify is whether it is supervised algorithm or unsupervised. Okay, or it is semi-supervised, or it is reinforcement. Okay, depending upon whether it's supervised, unsupervised, semi-supervised, or reinforcement, we classify them into four groups. Okay, if it is supervised, then we look at the target variable. Target variable is nothing but the y. Okay, the predictor or the y is also called as target variable, the one that we are going to predict. Okay, so if the target variable is continuous, right? Like marks or sales or rupees or dollars, right? Or temperature. These are all continuous values. So if that's the case, you're trying to predict the temperature, you're trying to predict the sales, you're trying to predict the housing price. We call it as continuous target variable. Okay. And if the target variable is continuous, we use a regression type of algorithm. So regression is a family. Okay. Regression will have again a lot of such algorithms. But at least we know here that we have to use a regression. What in regression we'll see tomorrow. Okay, tomorrow we'll go to regression and we'll see how to identify which algorithm is best. We will run a couple of algorithms and we will see the result. Okay, so so when we know, okay, so this is continuous variable. Okay, so we have to use regression, and you have a regression family of algorithms. Like example here is housing price prediction. If you have to predict the housing price, the price what will happen tomorrow, okay, the price that will happen after 6 months, after next year, after 3 years, okay. So that's the example of regression. If you want to predict the sales also, right, what temperature would be, right, that's also a example of regression. Then in supervised, if the target variable is categorical, talking about the category, yes, no, whether the customer will buy your product, yes, no. Then you talk about high temperature. Okay, so instead of finding the exact temperature, you want to find whether it's going to be low, medium, or high. Okay, then becomes a category, right? So in such cases, we use classification types of algorithms or classification family of algorithms. Okay, example is medical imaging. So when you look at your X-ray report, okay, any of the imaging X-ray report or any of those report, by looking at the X-ray, doctors will try to predict, right, or will say, okay, that looks like the patient doesn't have any problems. The patient is free, okay, and there's nothing, no medication required because there is no problem in the X-ray report. So sometimes looking at the X-ray report, you will say that no, there is a problem. Okay, there is a problem and it can have impact, okay, on the patient life. So they have to undergo surgery or take medication or do whatever, right? So what you're trying to do is as a doctor, they have learned about those images, right? In their medical school, when in their MBBS or MD, they have learned, okay, if this is normal X-ray and this is abnormal X-ray. If this is it, then this means it. Okay. So what happens is when you actually see the image, you're trying to link this to what you have studied as a doctor. You're trying to link it to your school, what you have learned in your medicine school, and then you say, okay, this is case of problem. This is a so that's called medical imaging. So problem, yes or no, right? Classification. Coming to unsupervised, okay, here you cannot have continuous variable. Okay, it can only be category. Okay, so for this category, then we have two types of algorithms from clustering and association. So example that I discussed before, like customer segmentation or store clustering. Those are examples of clustering. Okay, you're trying to group stores into different groups. You're trying to cluster uh, customer into different groups. Okay, so this is called customer segmentation, and this is part of unsupervised algorithm. Then you have association algorithm. In association algorithm, we are trying to find the association. Okay, so what is association? Association is if a person is doing this, what is the impact on other thing? Okay, means if I am, if someone is buying, again I'll go back to retail store because that's what my area of work is. So if somebody is buying milk, what all things go with the milk? Okay, so we go back, okay, we check the bills, and if you see, we'll check all the bills which has milk on it. Okay, so maybe you have say 100 out of 100%, 50% of the bills has milk on it. Okay, so we ignore 50% of the bill. In the 50% of the bill which has milk on it, we see what are the different types of items people have bought along with it. Okay, 1% people have bought bread. 30% of people have brought, say, eggs with it. Okay, so you know that milk and egg go together. So in that case, what I'll do is I'll put the egg and milk shelf together in the store. So when you visit any of these big stores, right, a supermarket, you will see that everything that they place there has a logic behind it. There's an association rule they have used, and based on that, they have put that. When you see bread and milk together, that means people who come for buying milk, they buy bread. People who come for buying bread, they buy milk. So let's say if I want to buy bread and I go there, and if milk is kept somewhere else, and I buy the milk and I come out, and then after going home I realize, oh, I should have bought milk also, right? Then what I'll do, I will not travel to that supermarket. We probably go to the nearest store and buy. As a retail store, I have lost the business, right? But if I put milk and bread together, and if I buy the bread and I look at milk, then oh no, I have to buy milk also, and then you buy the milk. So okay, so that's why what we're doing. An association rule will tell you what goes well with what. Okay, and this is type of supervised algorithm, and market basket analysis (MBA) is part of association. So what goes with what in your market basket? When you go to supermarket, you have that basket, right? So what should go in the basket along with the things that you buy? So they'll put milk and bread together, they'll put egg and something together, because they will continuously look at the different bills, and based on people buying pattern, they will put things together. Okay, so that is what we call it as clustering. Okay, sorry, association. Sorry, association. Okay, so in association, they are trying to figure out what goes well and what doesn't go well. Okay. Then self-supervised is a mix of that. So you have classification and clustering. And what is interesting here is the control. Okay, in control, which is under reinforcement type. Okay, it is example is driverless car. So in driverless car, and see, in driverless cars, you can't have many if else condition in a program, right? You can't have so many if else. So what we do here is we write the program based on feedback. So if I accelerate, what will happen? If I put brake, what will happen? If somebody is coming in front of the car, okay, the cameras will be there on the driverless car. So cameras will recognize something is coming. So something is coming, and that something is, let's say, 10 meters away or 10 feet away from you. At what speed or at what pressure should apply brakes so that it stops before you hit the person, right? If person is within a feet, you'll you'll put the brake suddenly, right? If person is 10 feet away, you'll put the brake slowly, right? All those decisions are taken, right, by a driverless car, and this is what we call as control. Control is where all these calculations are done by the program itself. There's no if else condition. If this, then do this. If this, then do this. No, right? Because if you write if else conditions, we can write how many conditions? You can write 100 conditions, 500 conditions, right? But if you drive any vehicle, or car or bike, you will know that lot of decisions we have to make for every trip. You have to move to the left, you have to move to the right. How much to the left? How much to the right? When should you apply brake? When should you put accelerator? When should you take turn? Right? So we make a lot more decisions in every trip. And if you have to make cars which takes its own decision, it's just not possible. Do it using if else. So you have to let the algorithm make decisions for you. Okay, that's what we call it as control or driverless car. Okay. So as I said, right, we will focus on regression and classification for our discussion today. Okay. There are some applications, okay, of machine learning, and this is what I have been talking, for some time now, talking about, how it can increase your efficiency. Okay. We don't have to write big lines of code. So typically machine learning code, and tomorrow we'll see, we can achieve a lot of things within just line or two lines. We don't have to write big lines of code to achieve your objective. Two lines of code and you are done. So it brings in efficiency to the process. It brings efficiency to our thinking capability. We can't handle thousands of data, thousands of rows of data, right? So the algorithms will help us to make those decisions better. Okay, we can personalize our marketing campaigns. Okay, so this is again another classic example which I want to talk about. We get so many SMS, right, every day. Okay, so let's say I run my own store. Okay, for that matter, let's say you're talking about Big Bazaar. Now, Big Bazaar has hundreds of items, right? They have shoes, they have grocery, they have dresses. Okay, they have um, say bags and purses and things not. So let's say if I'm running a grocery promotion, okay, I want to give 20% discount on grocery on today. I have got 10,000 phone numbers with me, okay, who are shopping with me. Now, general tendency is you send the message to all the 10,000 people, okay. You send message to all the 10,000 people saying that, oh, there is a discount in on our atta, okay, and today we're running 20% of discount on atta, okay. Now, all 10,000 people, will they be interested in atta? No, right? So maybe only out of 10,000, only 1,000 may be interested in atta. Other 9,000 are not interested. Okay, you run promotion on shoes, footwear, 30% discount today on footwear. Again, you send a message to all the 10,000 people. Out of 10,000, only 500 people are interested. Okay, so what is happening here is, as a customer, we get so many SMSs, marketing SMSs, and the problem is, out of that, only 1% we are interested in, right? So we are interested in only 1% of the information, of the product. So let's say I'm planning to buy shoes, right? And I get messages from 20% discount on Atta, 10% discount on watches, 50% discount on XYZ, and then comes fourth message, 20% discount on footwear. I'm interested in footwear, but what happens, because of getting so many junk messages, I'll stop seeing the other messages. I'll block Big Bazaar. So maybe out of 10, one message is important to me, But what I'll do, because I'm getting so many junk messages, I'll block Big Bazaar. I'll stop. Even if I don't block it, I'll stop reading the messages from Big Bazaar. So what is the problem with Big Bazaar? There is one customer who's interested in footwear. Okay, if the Big Bazaar has sent me just one message, I would have been happy to look at that message and probably I would have gone and bought. But just because they sent so many junk messages to me, I did not see that. So one, they're losing the customer, right? Second thing is 5 promotions and 10,000 to each. You are running 10,000 to 5, 50,000 SMS is being sent. Now, the cost of sending 50,000 SMS, of course, will be much more than just sending 1,000 SMS. So if I know that 500 people will be interested in shoe ad and Google sends only to the 500 people, they are saving money on sending SMS. So they are saving money on sending SMS, and at the same time, they are going to get real customer who's interested in. Now, it is easy said than done, right? I mean, there are 500 people interested, and you send message to 500. All 500 come. This is um, something which is very ideal, and probably it cannot happen today. Okay, but even if I know if it's a 500, if I know 2,000 people, I send message to 2,000 people, which is going to give me a better result, right? So, I'm not saying that you'll be 100% accurate, even if you're 25% accurate. I'm not talking about even 50%. If you're 25% accurate, so instead of sending messages to 500 people, you're sending messages to 2,000 people. You still save money on sending SMS one, and you're not making every customer angry. Correct? So we have to think of personalizing the marketing campaigns. Personalizing means people who are interested in footwear should only get it. Now, how do you do that? Clustering. Okay, clustering. You look at the what people have bought, and then you create a group. Okay, group one, group two, group three. In group one, you look at the characteristics. Okay, group one looks like people are buying only footwear related stuff. So you send only footwear related messages to group one. In group two, you send only one specific kind of message. In group three, you send. So you're saving money. You are not making customer angry, and customer is going. The more chances of customer reading your SMS and coming and buying the product. So sales will increase, your cost will go down, and your process timing is also saved. Okay, that's what we talk about personalizing your marketing campaigns, and this is possible only when you have a mechanism or you have an algorithm which goes through thousands of records, thousands of history of every customer, and then giving you the best result which you can use it. Right, and then of course there are a lot of other things like we spoke about recommendation engine, right? Recommending Amazon recommending product. Okay, you can read about detecting fraud and virtual doctor and writer and things like that. There are tons of applications. Okay, and some of them we have of course seen, and slowly when we do a lot more work, we will see some more examples. Okay, so I wanted to show you this data which says that if you see in North America, 95% of the businesses have already adopted machine learning. Okay, I'm not saying they have matured enough, okay, and their algorithms are working fine, but they saw the opportunity in machine learning and they have already adopted. Now, they could be at very basic level, nation state level, they could be advanced level. Okay, so we are not talking about that, but yes, there is the importance. They have realized the importance, and then comes Asia. Like 72% companies in Asia have understood or recognized the importance of AI ML, and they have adopted to some extent. And Europe is a little behind. Okay, so the reason I'm trying to say is that companies have understood. Okay, this is not just a subject for study. Okay, this is something which is serious, right? We all have to study and know, and you never know, right? In few years time this could become, and see, colleges have already started adopting machine learning topics, and they are giving training to their students. Okay, because when they come out and they go for job, they'll be ready to get into this kind of environment. Okay, so if you see, in few years this will become a mandatory or regular stuff. What we saw 5 years back as a privilege, if you were called data scientist 5 years back or 10 years back, it was like wow. I mean, sorry, 10 years back, nobody would give any value. They didn't know what data scientists do, right? So 10 years back, if a data scientist, probably nobody would have given any importance. 5 years back, they were like, wow, you're a data scientist. And 5 years from now, if you say you're a data scientist, doesn't matter. It'll not this thing, because everybody has to learn data science. Okay, everybody has to learn this topic and be able to work in this kind of environment. Okay, so any questions you have before we get into? So today I'm going to talk about pre-processing step. Okay, so we will do a little bit of hands-on. This is more from pre-processing. What else should we do before we actually run algorithm? Okay, so next almost 30 minutes I'm going to talk about data processing steps, the different steps that are involved in data processing. Okay, so we will perform that, and then tomorrow we'll get into complete hands-on of the algorithms. So any question before we get into pre-processing stage? You can put a question in the chat. You can ask me the questions. Okay. So I take it as no question. So I take it as complimentary, saying that you understood everything, and there's nothing to ask. Okay. So what I'm going to do now is I'm going to talk about different things that as a data scientist need to perform. Okay, and this role is also called data engineer. Okay, what I'm going to talk about now for next 30 minutes is called as pre-processing stage. And also, like when you get a job as a fresher, mostly you'll be doing this kind of work. Okay, before you actually start running the machine learning algorithms, you'll be doing more of data engineering and analyzing and cleaning and those kind of things. Okay, so we call it as pre-processing stage. Pre-processing stage means this perform or the activities that you do before you actually run a model. Okay, before you run a mathematical model or before you run a artificial intelligence or machine learning algorithm. Okay, so before you do that, we need to perform. We need to analyze what is called as pre-processing stage. Okay. So there are mainly four types of performance that you have to do. Okay, and we will take one by one and we will do it. But before that, okay, there are a few things we need to know. Okay, one is what algorithm is. Okay, algorithm is nothing but it's a set of mathematical operation. Okay, so for us it becomes a business problem. For mathematics, it's just numbers, and it will perform something. It'll give you some output. As we say in computer science world, right? Garbage in, garbage out. So if you provide garbage to the algorithm, he'll give you garbage. Okay, because it does not have any mind as such to know whether it's garbage or not, right? You give some number, it will perform something, it'll give you some output. Now, is that output usable? We have to understand, and that's where when you say someone is experienced data scientist, it means that that person is able to understand what is wrong, what is right. Okay, so the first thing that we do generally, okay, is called feature scaling. Okay, it's called as standardization or feature scaling. So when you get a data, okay, let me open an Excel and we'll talk about it. Okay, let me know when you can see my Excel file, guys. Okay, okay, so let's say you have just two axes. Okay, x1, which is age, and you have x2, which is salary, right? So we have x1 age and x2 salary, and based on age and salary, we want to predict whether your customer is going to buy your product or not. Okay, so this is y. Y is a predictor, and buy or no buy. Okay, so what we have seen. Okay, so I'm going to create a training set. So what we have seen is someone with age 21 and salary, annual salary of say 1 lakh, they don't buy a product. Okay, somebody with 29 years of age and let's say same salary buys your product. Okay, somebody with 21 years of age and let's say high salary buys your product. Okay, so let's say this is a kind of data set that we have. Okay, now this is of course y. Okay, so this is the prediction that we are going to do. So this is we'll treat this separately. Now here, since these are the input that you provide, okay, now If you see here, the age has just two places, right? It's a 2-digit value, and salary is 6-digit, 7 digits sometimes. Okay, when you pass these two data to the machine learning, since this value is big, okay, 6-7 digit, this is going to have much larger impact on the analysis, right? Now, in if you look from our experience perspective, age and salary are two independent columns. They should be given equal importance. Okay, but in this case, because salary is such a bigger number, it is not going to have or is because of its size, is going to have larger impact on age. And what we might see is that, okay, the age is not playing any important role. But in reality, based on experience, we know that age and salary both are important. So both should be almost like 50-50 partner in the analysis. So to do that, what we have to do is we have to bring both of them to a same level. Okay, so that between age and salary there is no difference, but within age and within salary the difference stays. Right? When you say 21 and 29, there's a difference between 21 and 29. That difference should stay. Between 1 lakh and 10 lakh, there is a difference, and that difference should stay. But 21 and 1 lakh, difference should not be there. Okay, because they are equally important for the analysis. Okay, so the first step that we do is called feature scaling. And feature scaling is, okay, so see here, we call them as predictor. Okay, these are called as features. So when you read features in a book or in blog and things like that, don't think of what this word is. Features means the input X that you give to the algorithm. Okay, so these are called features. Okay, so when I say feature scaling, we have to scale the features or the X's to a level where the two columns do not have much difference. Okay, now instead of age, if we had something else, I'm just giving an example. Let's say you have X3 here, and let's say marks. I'm just saying marks, okay? And you have marks like 50, 55, 65, right? And you only have X1 and X3, for example. Now, in this case, we don't have to do feature scaling, okay? We don't have to do feature scaling because both are, I know there is some difference, okay? But difference is not that big to have marks have a control over age. Okay, I mean, so marks will say average. Okay, that sounds better. Okay, so we can't have age have a bigger impact on the marks. Okay, they're in same range. So in this case, we don't have to do feature scaling. Okay, we don't have to do feature scaling on all the values. It's only done on the number first of all. Okay, so you can have another x, say x4. Okay, and in x4 you have, let's say, region. Okay, north, south, east, for example. Now in this case, we don't have to do feature scaling because these are categorical data. In categorical data, we don't perform feature scaling. For feature scaling is performed only on numerical data because these numbers are, you can perform, okay, so these numbers can have a different value. So here in this case, we don't perform. Okay, if you have values like this, so when you're a data engineer, when you get the input X, you look at the values in the column. And if I just said, right, if they are in the same range, you will skip this step. If not, you will perform the step. Okay, and when you're performing, you perform in all the steps. So if I have all these three columns in my data analysis, okay, I will perform analysis on all of these. Okay, so here in data feature scaling, we have two ways to do it. One is called mean max normalization. So this process is also called as feature scaling or normalization, okay, or standardization, okay, or mean removal. I'll talk about what it means. Okay, mean removal, or you talk about variance scaling. These are the names that we provide. Okay, mean removal, variance scaling, standardization, normalization, feature scaling. So here the first method that is there is called mean max normalization. Mean max normalization. Okay, so today we'll see in the Excel itself how it is done, and tomorrow we will see in Python, okay, how this is performed in Python. Okay, so you have min max normalization, and second is called Z score normalization, or using the standard deviation technique. Okay, called Z score normalization. Okay, so Z score normalization is nothing but using standard deviation technique, and we will see how it is done. Okay, in min max, what we do is we divide. Okay, so we do what is called as x. X is the value that we have here. X minus minimum of x. Okay, and that we divide by mean minus x, or max minus mean. Okay, max will be bigger, right? So max minus mean value. In Z score normalization, we use this formula. So we divide x minus mean of x. Okay, mean here, not min, but MEN, average. Okay, of x, of all the data set that you have, and that you divide by standard deviation. Okay, division divided by standard deviation. Okay, so we will calculate and I'll show you. So x1 mean max. Okay, so we'll do x1, we'll do x1, we'll do x2, and x3. I mean, we don't have to do it because you know you have to do it, right? So we'll do mean max first, and then we will use Z score method. Z score method, and similarly we'll do it for mean max and Z score. Okay, so here mean max x is 21. Okay, so before that we have to find the minimum and maximum, right? So here your minimum. Okay, so I'm going to write here mean and max. Okay, so mean will be mean of all these values, and max will be max of all these values, right? So to calculate min max, I perform 21 minus mean divided by max minus mean. Okay, so for minimum you get 0, and for maximum value you get 1. Okay, so you get 0 here because x minus mean, and because its mean is same as x, right? Of course you get 0 by anything is 0 only, right? So if value is mean, you get 0. If value is max, you get, this one will be 1, because max minus mean divided by max minus mean, so it'll get cancelled out 1, and we'll put something in between. Okay, let's say we'll put 26 here in between to see how it is done. So what I'm going to do, this value will remain same, but this should, I mean, A3 should change, but F7 should remain same. So I'm going to fix it. I'm going to fix this one, and I'm going to fix this one. Now when you do it, so you see, so which was 21 became 0, and what was 29 became 1. So when you do min max, the value range from 0 and 1. Okay, so minimum value is 0, maximum value is 1, and other values gets adjusted based on the minimum and maximum value. Something which is 26 here will become 0.625. And instead of using this into our analysis, we will use this value in our algorithm. Okay, it's called min max method. But the most popular method is called Z-score method. Z-score is the most popular. Okay, so in Z-score, what we do is we calculate average and then we divide by standard deviation. So um, 21 minus mean is average, right? Average of all these three things, and that you divide by standard deviation. So STD, DE, STD, EV, okay, and standard deviation of all these values. So standard deviation range from -3 to +3. Okay, it can range from -3 to +3 any value. So here again, x will should remain same. Average should be fixed. So I'm going to fix it, and standard deviation should also be fixed. So I'm going to fix it. Okay, and then okay. So this is what z-score means. Okay, and of course, like you must have done z-score in your probability distribution. Same concept here. So when we to show you. So generally when we have this normal distribution, correct? So when you have normal distribution, okay, pardon my drawing, it's not straight, but yeah. So what happens is this is where the z-score, what it'll do is it'll normalize it to 0, right? So something which is below average will be negative, something which is above average will be positive. Okay, so this is what z-score would do. This is z-score. Similarly, z-score of x2 also we have to do it. Okay, so we will find the minimum maximum of this value here. No, this is minimum maximum of not C3 but B3, right? So we'll say B3 and B5. Okay, so same thing here, B3 and B5. Okay, so min max, the number minus mean divided by max minus mean. Okay, and min max we will fix it. F4, shift F4. Okay, and then I'm going to drag it. Okay, so these are same, these are minimum, so you got 0 maximum. So what we'll do is here I'll put something different so that we see this. Okay, so see here I gave 3 and this value became something like this, close to 0, because this is close to 0. If I put one more 0, it becomes even more big, right? So somewhere between, you get 0.5, right? So what it has done is it has reduced the value, or reduce is not good word. It has scaled the value. Okay, scaled is the right word. So we have scaled the value between 0 and 1 here, and 0 and 1 here, and z-score again we say x minus average of this divided by bracket close, divided by a standard deviation of these values. Okay, so as I said, value will range from -3 to +3. Closer to 0 means it's closer to the mean, right? Closer to the z value 0. Okay, so average will be fixed. So I'm going to say F4, 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 F4. Okay, so this is how the value will be scaled. We are scaling the value. Okay, so tomorrow, as I said, tomorrow we'll take a data set and we'll perform all these operations that we're going to discuss. Okay, so this is the first thing that we have discussed. First thing is to perform the scaling or feature scaling. Okay, so that the columns. Okay, so this is based because of the columns. Okay, so that column values range in the same manner. As I said, right? If you take x1 and x3, which values are almost the same range, we don't have to perform this feature scaling. Feature scaling is performed only when the two columns will have very large difference in the values. okay, compared to column A versus column B. Okay, not within the column. Okay, within the column, we want to maintain the difference. Okay, if somebody is getting 1 lakh salary, somebody is getting 1 crore salary, the difference has to be there because that's how the value is, right? But compared to two values, we don't want one column to have a bigger impact or create biasness in the system. So we do feature scaling. Okay, so the first step that we do is called feature scaling. Okay, then we also know why it is done. Okay, then we do missing value. Okay, how to handle the missing data. Okay, so so this is the step one. Let's say we create a step two here. Now here again I have, let's say I'm sorry, let's say you have region here. Okay, and I'm going to copy same stuff. Okay, let's copy same data. Let's say this is the data set itself. Okay, so let's say age is missing. Let's say salary is also missing here. Let's say X3 is also missing here. Let's say here North is missing. Okay, let's say here this is missing, for example. This is the data set we got. Okay, there are some missing data, and now of course we're looking just three, but you can extrapolate for thousands of record. Okay, now there are two ways to do it. One way is remove all the columns, or sorry, not columns here in this case. In this case, we are focusing on rows, right? So remove all the rows, because see, these rows together, okay, will have impact on this by. These together will have impact on this by. These together will have impact on this by. So the step one, what we do is, okay, we look at the missing values, and one option is you remove all the rows which has missing values. Okay, missing values we can't work with, so I'm going to remove all the missing values. That is method one, step one. First method is remove the values. We remove the rows. Okay. Second method is, okay, so what is the problem with the first method if you remove? Okay, one, there could be some rows with some missing values, and if you remove it, what happens? In this case, if I region is missing, okay, if I delete this complete row, these, even though only one value is missing, I'm losing other three values also, correct? Because one value is missing, because of one value is missing, if I delete the row, whole other values which are there, I'm missing that, right? That's the problem, that you're losing value that you have also, you're losing it. So what we do generally, we look at the number of columns for which values are missing. And if there are large number of columns values are missing, okay, so then we delete it. So in this case, row number 4 is a good example of deleting it. Okay, because here we have very few data available. Lot of the columns have missing values. So if I delete this, this probably will not have any bigger impact on the analysis. Okay, so I'm going to delete this row. But in other cases, here and here, okay, problem is that if I delete one this row, I'm losing three values. If I remove, this row, I'm losing other three values. Okay, so in that case, we follow second method. In second method, we replace with most probable value. Okay, now again, see, if your purpose is to do data visualization, to show the data to your stakeholders, to your management, to your team, to your manager, to your colleagues, in that case, if you replace that, okay, with some value, okay, which seem like correct value, then it will give a wrong picture. In that case, what we do is, okay, and this is when talking about data visualization, okay, where you want to just project the data. No, you don't want to perform the machine learning algorithms. In such cases, we represent these values with, say, -999. Okay, not right. We'll say NA. Generally, we see NA in the number, right? or minus 999 or something like that. So when you see the when you draw the graph and when you see minus 999, graph is something like this. So you know that, oh, okay, I need to ignore this, right? And similarly, it says NA, you know, oh, I need to ignore this because this is not applicable, not available data. So I'm going to ignore this. Okay, when you're doing data visualization, it is good practice to write some specific word which will tell the reader that, oh, data was missing. Okay, if I make it north or south or east or west something, it is going to give the wrong image to the reader. It will give wrong image to the reader that this data is is there. So if there are 10 missing columns, if I make all the 10 to north, it will give a wrong image that north is 10, has more data than others. Okay, so it is not good practice to replace this with some other values, but you replace with some different unique values which people can make out, oh yeah, this is not available, not applicable, not interested on that kind of data. So in that case, we do minus 999, we replace with say something like NA. But when you're doing the machine learning algorithm, okay, in machine learning algorithm, we are not talking about each row or each value. We're talking about the complete entire data set, right? So out of 1000 rows, okay, I'm talking about less number of data. I know generally you have 5000, 10,000, and sometimes millions of rows. In smaller data set, even if you take smaller data set, if because of 1000 rows, if 5 columns or 5 rows has that kind of problem, okay, it's not going to have bigger impact. So to negate the impact of this particular column on the analysis, we give the average value. So when you put the average value, okay, in the machine learning algorithms, average values will not have any kind of adverse impact on the machine learning analysis. So if I have this data, let's say I have 21, 22, okay, and this data is missing, let's say, so I'll put 22.5, okay, average or mean of this data. So because mean, the average will not have much impact on the analysis. Average values will not have analysis impact on the analysis. So we create as average value, and we continue our machine learning algorithm. So machine learning algorithm will see, oh, average value probably it will analyze, okay, because there's no way to tell machine learning that ignore this value. There's no way, okay. So we uh, put it average so that it will have very minimal effect or impact on the analysis. So on the numerical value, you perform average. This is not numerical. This is categorical value, right? On categorical value, what we do is we look at the maximum occurring value. Okay, so that becomes like a mode of that column. So in numerical column, we take mean of the column, and for categorical value, for categorical values column, we take mode. So let's say if north is appearing maximum number of time, we replace that with north. Okay, so see, in visualization, if you put north, it gives a wrong image that, oh, so many values from north are there. But when you perform the analysis, machine learning analysis, in that case, putting mode will not have any adverse impact on your analysis. So in second method is replace the missing values. And how will you replace? If numerical, then replace with mean or median. Okay, you can replace median as well. Okay, it's up to you. And for categorical value, replace with max occurring. Okay, or the mode. Okay, or the mode of that thing, right? Mode means maximum occurring member of the group, right? So replace with mode. This is how you handle the missing data, okay, in machine learning type of algorithm. Okay, so we have seen how to perform missing value. We have seen how to perform feature scaling. Okay, so these are the work that you have to do before you actually run the algorithm. Okay, we have to make sure that our data does not carry garbage, because if you put garbage in, you get garbage out, right? The third thing that we have to do is called outliers. You have to figure out outliers. Okay, and outliers we remove it. Okay, so let's say you have age, and let's say there's a value comes in with 98 years or 198 years. Okay, so when you have 98 years or 198 years, 198 years clearly it shows it is wrong. This data is wrong. So if data is clearly wrong, okay, then you replace, you make it blank and you perform the missing value. Okay, 190 wrong data is same, is missing value is better than having wrong data. Because wrong data can give you a, especially when we talk about outliers, right, it will have a very big impact. Okay, so we make it average so that it does not have bigger impact, right? So when there's outliers, we generally replace treat that as a missing value in machine learning algorithms. Okay, we treat this as a missing value and perform that. On what are outliers? So you again, I'm not going to get into that. But missing value, sorry, outliers are the values which which are mostly beyond z score of 3. Okay, so when you talk about normal distribution, something which goes something like this, these are your outliers, right? These are kind of outliers. So we fix a z value, saying okay, this is the z value that we want. Beyond this value are outliers. So you can decide what you want. Do you want outside 5 5 sigma or 4 sigma or 6 sigma or 7 sigma? You decide your outlier values, and more than that sigma values will be considered as outliers. So outliers is treated same way as missing value. So you replace the outlier value with average or mode value. Okay, so that's how we handle outliers. The fourth one, okay, and also the probably I would say most important one. Okay, this is very important to understand the concept, and this is also when you go for machine learning interview, this is a very common question that everybody asks. Okay, answer is how to handle categorical data. So when you take this example itself, okay, this is why. So this doesn't matter. We can convert, okay. So we can convert when you provide this. Okay, so machine learning is all about mathematics, and when you provide north, south, y, n, it cannot perform the analysis, right? Because it's a mathematics. So we have to convert this into number. So what do we call it as? We call it as label encoder. Label encoder is you encode the label. So treat this as label, north, south, east. And what I'm going to say is I'm going to say, okay, I'm going to encode. Okay, so I'm going to say x4 encoded. I'm going to say this is north, I'll treat as 0, south as 1, east as 2. So I'm encoding, okay, a text data to a numeric data. So this is first step. Okay, so same way when you are doing y also, we have to encode y. Okay, and y will be encoded as, and say no, and y1 y1. Okay, so this is how you get 0 1 1 as encoded data. Okay, so y there's no problem, but x, when you encode, the problem comes in of scaling problem. What? Why scaling? So when you give 0 1 2 to the machine thinks 2, in this case east, has lot more impact, has lot more value than north and south. But see, these are just labels. Okay, categories are just labels. For the analysis, all these three things should be treated as equal. East is not more powerful than north or south is not more powerful, or north is not more powerful. All of these things should be treated as equal. Okay, so this One more additional step. In fact, there are two more. We'll talk about one more, and then we'll talk about the last step. So there's one additional step that you have to perform after you do label encoding. Okay. So after you do label encoding, so you look at how many values are there. In this case, we have three values: north, south, east. There's no west here, assume. Okay. So we only have three values here. So we have to convert this one column into three columns. We don't want machine to give this two as more important than one and then zero. So we have to convert this one column into three columns so that all the three columns have equal importance in the analysis. So this X4, which is your region, okay, becomes four regions, okay. So you can call it as X41, X42, X43, or you can call it as here north, south, and east. Okay, so one column, one categorical column becomes multiple columns, and the number of multiple columns is same as the unique value in the column. So here we have unique value as north, south, east. So it becomes north, south, and east. So here you have north, right? So what happens? North gets value 1, it gets value 0. It means we are saying north is present and south and east are absent. So you have to look at all the three values. So I'm saying one north and south and east 0. That means north is present, south and east is absent. Then next is south. So I make it 0. I make this as 1. I make it as 0. So I'm saying south is present, north and east are absent. Same way I perform east here. So I say 0, 0, 1. So this is step 2. Step 1, encode it. Step 2, convert into multiple columns, same as the number of unique element in the category. Third step, okay, the third and the final step. When you perform this, okay, so let's say if I, okay, so this is called dummy variable trap, okay. This falls into trap where the machine or the algorithm will think these three are separate variable because it has 0 and 1, 0 and 1. So this could be treated as separate variables, and the purpose of making them think that these are same will go away. So what we do is we delete any one row. You can delete this one or south or north. Anyone you can delete it. Now, when you see here, one means north is present and others are absent. South and the third one is also absent. So for algorithm, I told you what matters is the numbers, not the label, right? So whether you call it south or east or you call it A or B doesn't matter for the algorithm. So it knows that okay, one is present, that means this row is present, sorry, this column is present and other columns are absent. This is absent, this is present. In this case, what it thinks is north is absent, south is, oh, both are absent. That means third column is present, assumed, right? You can assume it. So if you delete it, it will not have any impact on the analysis. In fact, it will have a positive impact that they will treat these two things as together. I'm sorry. Okay. So this is the fourth most important step that you'll perform before you actually perform your machine learning algorithm. Any questions so far? So we discussed about feature scaling. We discussed about how to handle missing values. Okay. Then we discussed about outliers. Okay. And then finally, to handle the categorical data. Categorical data is little more lengthy. Okay. And it will take a little more time for you to understand. Okay. But this is important from even from interview perspective as well. Okay. This is a good concept and we have to do this. So all these things steps are performed in pre-processing stage. So before you even run the algorithm, you call the model, or whether it's regression or classification or clustering, you have to perform all these steps. Okay. Then one more concept, we'll do it before we wrap up. and that concept we will again start from there tomorrow. Concept that we're going to talk about is the training set and test set. We have already discussed what is training set and test set. So what we do generally is we take the data from same data set. Okay, so this is the data set that we have. Okay, so we decide, okay, now here we have say 3 rows. Okay, of course I said, right, we'll have thousands of hundreds of rows. So we say, okay, 10% or 20%, generally 20 to 30% we select, we will keep aside for testing. So we don't expose all the data to algorithm. We say, okay, I will give only these two data to algorithm, and this I will hide it from the algorithm to test the algorithm whether algorithm is predicting correctly or not. So I'm going to give these two data to the algorithm to learn. So it has X and it has Y. So using X and Y, it is going to learn. So this is, again, I told you, part of supervised algorithm, regression or classification, right? So we are providing these two set of data. Two means first is XS, and then we call it as Y. So this is called X train. Okay, X training data and Y training data for the machine to understand, learn what is happening. And then after training is done, to test the machine, we provide only X test. We don't provide the Y. We will give this and ask machine, predict it for me now. Machine will predict it as, say, N, for example. So this is called no. I mean, predict Y predict. Okay, so Y machine is predicting as no, but in actual we have yes. So that way we know that the model that we have used is not working correctly. Model is not giving us right result. Okay, so this we have hidden. We did not tell it to the algorithm. Okay, and then we gave this value and we asked it to predict. So it predicted no, and then we compared. Oh no, this algorithm is not good. If it predicts yes, why? Then you compare, oh yeah, algorithm is predicting correctly. So this algorithm is probably right algorithm for this problem. Algorithms will change based on the problem. The algorithm that you will use to predict car sales will not be same as the algorithm that you will use to predict toothpaste sale or grocery sale. So the algorithms will change based on the problem statement. And how do we know which algorithm is best? There is no easy way out than running all the model and testing it and then telling this algorithm is giving us better result than rest of the algorithms. Okay, this is what we'll see tomorrow. Any questions so far, guys? So we discussed what is machine learning, right? We discussed what different types of learning that we have. We discussed different types of algorithms, the families of algorithms that we have, right? We looked at the pre-processing step before you actually run the algorithms. What are the different steps you need to perform? And we have used Excel today. Tomorrow, our algorithm will be based on, we will do everything on Python. Okay, so we'll do the pre-processing step. We will do algorithm running, and we'll also do post-processing step. Okay, and to see how the complete end-to-end machine learning algorithm is actually implemented. Okay, so I end my discussion here for today. Tomorrow we'll talk more about training set, test set. We will perform all these same operations using Python on a actual data set, and then we will run different algorithms, and we will also do post-processing of the algorithm. Okay, so yeah, that's all I had for today. And let me know if you have any questions. If no, we'll end it here for today, and we'll see you tomorrow at the same time, 10 o'clock, and we'll continue for the second part of our workshop. Sounds good, guys? Okay, so I'm telling you what software I'll be using tomorrow. I'll be using Python. Okay, Python 3, of course, Python 3, and I'll be using PyCharm. So if you want, you can download these two. Both of these are free. PyCharm Community Edition. Okay, so PyCharm Community Edition is free to download. Community Edition and Python. So this you'll get it from python.org website, and this you'll get it from jetbrains.com. Jetbrains.com. So these are the website from where you can download this software, and we'll be using these two software to implement what we discussed today using Python.